Right, today we are going to do about the refraction by spherical lenses. All right, so lens is that portion of a transparent optical material, all right, having one or two spherical surfaces. This is example of one lens. Okay, this is a convex lens which I'm using. So there are two kinds of lenses. One is convex lens and another is a concave lens. Now, this is a convex lens. These are the convex lenses. Here we have got convex lens, which is thicker in the middle and it is thinner at the edges. There are three types of convex lens again here. You will see this is the first one, which is a double convex lens. All right, there's two spherical surfaces here. This is known as the plano-convex lens, which is one side plane and one side convex. The third one is the concavo-convex lens. That is, one side is concave and the other side is convex. These are the three kinds of convex lens. When we have the concave lens is the lens which is thinner in the middle and thicker at the edges. That it is thinner in the middle and it is thicker at the edges. Again, here in the concave lens, there are three kinds of lenses. Double concave lens, where both the sides are concave. All right, this is a plano-concave lens, where one side is plane and the other side is concave. Then we have the convexo-concave lens. One side is convex, bulging, okay? The other side is concave, like a cave. These are the three kinds of lenses. Let us look at the terms which are used in lenses. The first one is the principal axis. These are the terms that you will be needing in this chapter. First one is the principal axis. Now, if this is the convex lens, okay, this side is a part of this sphere, imaginary sphere, and this side is a part of this imaginary sphere. This is the center of this sphere, and this is the center of this sphere. Then, if we have an imaginary line joining the two center of curvature, C1 and C2, all right, then this imaginary line, we call it as the principal axis. Now, if we draw a line here through the aperture, that is the diameter of this lens, this line cuts the principal axis at a point inside the lens. This point is called, I am naming here as O, it is called as the optical center. Now, you will see, this is the next one which is quite important, that is the principal focus. All right, of a convex, first we will look at principal focus of a convex lens. Here we will see that what is this principal focus of this convex lens. First of all, we will see that in a convex lens, all right, there are two principal focus, unlike your mirrors where there is only one principal focus. Okay, the first one here is F1. Now this F1, it is the first principal focus, and we have the second principal focus also, but first let us look at this F1. So if we have rays coming out from F1, this is your convex lens. Okay, I've drawn the convex lens beforehand along with the aperture, that is diameter, and the principal axis, and this is the optical center O in the middle. If we imagine rays coming out from the focus, these rays, when they pass from the air through glass, they will suffer refraction because there is a change in medium from air to glass. All right, we know that there will be refraction, there is bending of light will take place. These light rays will now be emerging out from the spherical lens. All right, if this is spherical lens is made of glass, then it will be emerging parallel to the principal axis. All right, so this is the first principal focus. All right, it is the point from which rays of light emerging, all right, and falling on the lens after refraction will become parallel to the principal axis. The second principal focus is that if the rays of light are coming parallel to the principal axis, okay, of this lens, after refraction they will converge. Actually, they are going to converge at the second principal focus. So this is for the convex lens. But for the concave lens, again, so it is going to be slightly different. Okay. Now, if you imagine that there is a plane at this point F1 and this point F2, then this plane is called as the focal plane. Imagine if there is a plane here at the focus, then this is going to be the focal plane. Now, second principal focus of, let me talk about the concave lens. All right, concave lens also will have two principal focus. Here, let me talk first about the second principal focus, that is your F2. Rays of light now which come and fall here, which will appear to come, actually here it is not going to come, these rays of light which are supposed to fall in this first principal axis will actually, they are coming in this direction of the second principal focus, but because of refraction they are going to emerge parallel, right, parallel to the principal axis. So if it is a point on the principal axis at which the incident ray would have converged, this is the point on the principal axis at which the rays would have converged. All right, but after refraction through the lens, so this is your concave lens, it will emerge parallel, becomes parallel to the principal axis. This is this second principal focus, F2. Now, the first principal focus, F1, is a point on the principal axis where the rays, here you will find that the rays are traveling parallel to the principal axis. They will suffer refraction. Okay, suffer refraction. That means this is how they are suffering refraction. They move away, and if we produce them backwards, they meet here. These rays, they meet here. I'll show it from the textbook, it's more better. Here you will find that these rays, all right, coming parallel to the principal axis after suffering refraction, all right, they are going to, this is going to be their path. That is, they are going to move away from the normal, what we say. Now this is, if we retrace back, that means they would appear to be actually coming from F1. So this is known as the first principal focus.